an electric field is given to be having this sort. It has, is it one-dimensional or two-dimensional? It's having only Z in it. And you see that how is it a function of Z? Because it is going to have 15.7 kz. So it is of the form omega t plus or minus kz. So you see this omega is this term here. The k is this term here. And of the plus or minus, you got a plus here. And what is the component of the electric field? It is having x component only. So you're having only Ex, your Ey and Ez are 0. Okay. Obtain the amplitude of the electric field. What is the amplitude of the electric field? That means what is the maximum value the electric field can take? The frequency f, the wavelength lambda, and the phase velocity Vp. What is the direction of propagation of the wave? What's the direction of propagation of the wave? So E naught is going to be the amplitude. Amplitude is E naught, and that is going to be 2 volts per meter, because this guy is going to have from plus 2 volts per meter to minus 2 volts, yeah, because cosine changes from +1 to -1. The frequency is, how do you find the frequency? We know what is omega, is 3.14 into 10 to the power 9 per meter, and K is 15.7, sorry, per meter, radians per second. This is radians per second. It's going to be radians per second in this case, and this is K is going to be 15.7 per meter, but K is going to be 2 pi over lambda, and omega is 2 pi f. From here, I can find my f to be omega over 2 pi. If I do that, we're going to get 0.5 into 10 to the power 9 hertz, which is actually 500 megahertz. Mega being 10 power 6. 10 power 6 is megahertz. How about the wavelength? Wavelength is going to be 2 pi upon k. If I were to use this equation, wavelength will be 2 pi upon k, and that's going to be 0.4 meters. The phase velocity, the final one that is asked, is going to be f times lambda, and that is going to be 2 into 10 power 8 meters per second. So that's going to be the direction, that's going to be the phase velocity. And notice that this phase velocity is less than c, which is 3 into 10 to the power 8 meters per second. So the phase velocity must always be less than the speed of light. If your phase velocity is greater than speed of light, something somewhere is wrong, because nothing can be faster than the speed of light. Then the final question is, what is the direction of propagation of the wave? So we see that this clearly is of the form 2 cosine omega t plus kz. So since we have a plus kz, the direction of propagation is going to be minus z direction. Since it's a plus, it's going to be in the minus z direction. If it had been minus kz, then it would have been in the plus z direction. So if it's plus, it's minus direction. If it's minus, then it's plus direction. So it's other way around.